Okay, number 20, this is on review 2, exam review 2, number 20. We're going to find the fourth term of 3x plus y to the fifth. So we know the fourth term, like all terms, will have a number, a power of 3x, and a power of y. If we were doing the entire expansion, the first number would be 5c5, and then 5c4, 5c3, 5c2. So there is the fourth number. When we put our powers on, remember we count down exactly the same way. So the power on the 3x would start with 5, and then go to 4, and then 3, and then 2. These are the same. And then these two have to add up to that, so this has to be a 3. So 5c2, the number is 10. Then we're going to multiply that by 9x squared, and then by y cubed. So your answer is 90x squared y cubed. 21 we skip because that's not one of the ones that you're responsible for. So then, if you're in the college prep class, so now we have 22. There are 48 students on retreat. And they like to pray and sing. And they all like to pray and sing. So there's nobody out here. They all are either in the P or the S or both. 35 love to pray. 20 love to sing. And that's a little bit problematic because that adds up to 55 kids, and I only have 48. So some of those kids like to do both. Since there are only 48, there must be 7 kids who like to do both. The whole P ball is 35, so this must be 28. The whole S ball is 20, so this must be 13. And the question is, how many like only to pray? 28 students like only praying. Now we have 3 yellow, 7 blue, 10 green candies. William's going to pick 3. What's the probability he will get exactly 2 yellow? Now, this is a probability question. So just like the card problems, your denominator is going to be 20C3 because there are 20 total candies and you are picking a total of 3. In a card problem, that's 52C5. 52 cards, picking 5. 20 candies, picking 3. Now, William wants exactly 2 yellow. So there are 3 and he's going to pick 2. And then he's going to pick another candy. There are 2 of them, there are 17 of the other 2 colors. There are 17 candies, and he's going to pick 1 of those. So here are the 2 yellows, and here is the 1 not yellow. So I'll type that in on my calculator. And you hopefully are practicing with me. We get 0.0447. 0.0447 is the probability that he will get exactly 2 yellows. Now Miriam did 3 homework problems on the first day, 7 on the next day, and 11 on the next day. The question is, how many did she do on the 90th day? So I'm going to give you your formulas like I did on this last quest for your arithmetic and geometric things. You got to recognize this is arithmetic, and you have to recognize that you are looking for the 90th term. You're looking for a sub 90. So it will be 3 plus the common difference, which is 4, times 89. That's it. So how many problems is she doing? 359 problems on the 90th day of school. Good for Miriam. Now, this next one, when we did these, we found a whole bunch of stuff and we graphed them. You will not be graphing. You will be finding some of the stuff. So on this particular worksheet, remember you have 2 review sheets, we're finding the vertical asymptotes and the X-intercepts. So the first thing I recommend doing is factoring the thing. Factor the top and factor the bottom. And as soon as you do that, you notice you can cancel, and this becomes your problem then. X minus 2 over X plus 5. Vertical asymptotes are what X cannot be. So obviously X cannot be -5, so your vertical asymptote is X equals -5. Now, X-intercept is the value of X when Y is 0. So go back to your equation. 0 equals X minus 2 over X plus 5. Multiply the X plus 5 over to here, you still have 0. So X is 2. Your X-intercept is 2. Okay, if you, I believe the other worksheet asked you for the horizontal asymptote and the Y-intercept. You want to make sure you know how to find all that stuff. Okay, now we got the limits. So the limit for A is 5/2 because you have 5x squared over 2x squared, so that's 5/2. And B is divergent or no limit because 5/3, the number being raised to the power, is more than 1. And when that number is more than 1, you have no limit. 1.23 repeating. Now we're going to change that into a fraction. So you got 2 decimal places repeating, so it's 0.23, 0.0023, and so on. This one is separate, so I pulled him off, and then I have my repeating decimal. Since I have 2 places repeating, my ratio is 0.01. The bar is over 2 numbers. Your ratio is 0.01, 2 decimal places repeating. Again, I'll give you the formulas. You got to recognize which one to use. You're going to use your infinite geometric series formula. So the sum of this part only, I can't do that yet. That's not part of the repeating, so I'm just doing this part only. That sum will be 0.23 over 1 minus 0.01, which is 0.23 over 0.99. Now, that's going to be 23 over 99 when I move the decimal point to remove the decimal point. But don't forget, you still need to add that to the 1. So 99 99ths and 23 99ths gives me my final answer, 122 99ths. Remember, when you use your formula, you can only add up the repeating part. So the repeating part gets added with the formula, and then the non-repeating part gets added on afterwards. And finally, we've got a regular pentagon, 5 sides. And we know the radius is 8. And we're going to find the area of that thing. Hopefully, you remember dividing it up into triangles. You know that each of these segments I just drew in are 8. You know that all these triangles are congruent to each other, regardless of my picture, they're all congruent. You have 1, 2, 3, 4, 5 angles adding up to 360. So this angle right here is 360 divided by 5. All these are, which is 72. So the area of the triangle is 1/2, 8 times 8 times sine 72. Kids, we just talked about that in an earlier problem. So 1/2 times 8 times 8 times sine 72. I got 30.43. Now, that is just the triangle. I'll take that times 5, and the area of the Pentagon is 152.17 square centimeters. And that's it. Good luck.